Yeah, so thank you very much, Eleanor, for organizing this and for inviting me to talk about this project where we work together. This is going to be like a brief case study. It's a project. So just to introduce myself first, my name is Leandro Junges. I'm a research fellow at the University of Birmingham. And in this project, we were working to define and to validate a digital biomarker of epilepsy in children. This was a collaboration between the center where I work in Birmingham, the Center for Systems Modeling and Quantitative Biomedicine, and the company Neuronostics, which is a health tech company based in Bristol. And the project was financed by SBRI Healthcare. So just to give you a very brief background and the idea of this project. So this was in the context of epilepsy, which I don't know how familiar you are with this. It's a very common neurological disorder, affect around 50 million people all over the world, of which around 10.5 million are children. Epilepsy is basically a predisposition to the generation of epileptic seizures, which are by definition symptoms due to abnormal neuronal activity. So basically, epileptic seizures are electric storms in the brain, and epilepsy is a predisposition to have unprovoked seizures. The real challenge, or one of the big challenges in epilepsy, is diagnosis, because diagnosing epilepsy can be very, very challenging. So basically, when someone is suspected of having epilepsy, neurologists rely basically on the description of the symptoms by the person suspecting of having it, and basically eyeballing brain data. For example, EEG is a standard brain data, which is a measure of electrical activity in the brain, of brain waves. They also look at MRI images to try to find any lesion or anything physical in the brain that might be explaining the emergence of the seizures. But it's currently the state of the art in terms of epilepsy diagnosis is quite qualitative. So there's a lot of potential for improvement by better inquiring the data available. So the question is, can we combine this brain data that is currently being eyeballed and advanced data analysis techniques to try to identify biomarkers of epilepsy and with that support epilepsy diagnosis? So Neuronostics have been working for quite some time on that. They have developed a network-based biomarker based on background EEG, so electroencephalography recording of brain waves when the person is sitting down without doing anything specific for adults. So this is basically the very brief description of the structure of how the technology works. So you take a short segment of the EEG where we say uneventful, so it doesn't have any immediate sign of seizures or anything associated to seizures. That is used to build a representation of the brain network, what we call a functional network, which is calculated with phase correlation between the signals. Then this network is analyzed. We extract important information from this network, like the degree of the network clustering, the efficiency of how information flow from one point to the other in this network. So the characteristics of these networks then will represent the biomarkers to support diagnosis. So basically, it's understanding the differences of these networks between people that have epilepsy and people that do not have epilepsy. So these have been reasonably established in adults by Neuronostics. So the goal of this project was to extend these network-based biomarkers from background EEG to pediatric epilepsy. The brains of children are quite different, so we wanted to understand how these markers work for pediatrics. There's a lot that has been happening in this project, but I think that what is really relevant for our discussion here is that the pipeline for data analysis was computationally quite intensive for this project. So things like data upload and pre-processing, we had to do a lot of things with the EEG, like normalization, filtering, re-referencing, epoching. Then we have to calculate signal surrogates, which is reproduce similar signals with the same synthetic signals with the same statistical properties for statistical significance. Then to calculate the networks, then to calculate the network markers, and then do the analysis. This was computationally very intensive. So what we did, we use the supercomputer in the University of Birmingham is Bear, a part of Bear, which is the Birmingham Environment for Academic Research, and Blue Bear are the supercomputer there. But basically, a supercomputer, a server with several very powerful processors available that we can run things in parallel, which is very useful. I'll give some characteristics of the supercomputer there. But as Elena was saying, high performance computing can have a strong environmental impact. So what we did in this project, in order to minimize emissions from this project, we work in collaboration with Eleanor and her team to try to minimize that. So basically, we track and analyze the emission on a monthly basis to understand, or at least what we expect to be happening in terms of emissions. The emissions from the use of supercomputers were estimated using Green Algorithms Toolbox, which is a toolbox I think is managed by the University of Cambridge. So we have an idea of the of emissions of this project, and then we develop strategies to try to reduce the computational times. Some of the actions that we use to reduce emissions. So improve the debugging and the testing process. So try to optimize the debugging process and move as much away from the supercomputer as possible to personal machine. I try to make all the algorithms as modular as possible in a way that I could focus in individual modules and avoid as much as possible to run further modules when something goes wrong with one of these modules. So I can basically have more control over what I'm doing and target the optimization a bit better. Run as much as I could these modules locally, and I try to optimize the running times generally in all these modules. Try to make the code as efficient as possible, not just to save time, but also to minimize emissions. With these actions, we basically have an estimated reduction in the supercomputer use by 280 minutes. This was a relatively short project, 6 months, so this is actually not an insignificant amount of time that we saved from running these processes in the supercomputer, which led to an estimated reduction in emission of 0.65 kilograms of carbon dioxide equivalent. This is just in the bottom here is just a print screen of the Green Algorithms calculator. So just to finalize, a couple of take-home messages from our experience. The first is be aware of the environmental impact of the digital tools in general. Just awareness of that is very important, and not many people, I can say from personal experience, have that in the background of their mind when they're using digital tools. And having that awareness is very important to start taking measures to minimize it. Try to obviously optimize the use of any digital tools, either if it's your own code, which is it was our case, or toolboxes that you're using. Try to understand them and see how you can optimize its use. Use of large language models like ChatGPT, try to use it in a way that's smart as possible. Storage is also very important. Try to use it as in an intelligent way as possible to minimize its use. And have in mind that a little can go a long way. So you can do, if you make small changes in all of that, it can end up adding to quite a lot. And if we all do that, that ends to enormous amounts. And something that I personally think it's very important is to either identify, or when they're not immediately available, to create personal incentives to stimulate best practices. So it's very difficult for us to take time, many times, to take time to optimize what we do for something like environmental impact. We have competing incentives, to go and do something else. If we can, I'm going to use the word capitalize, but I mean this in the best possible meaning of this word. If we can capitalize on our actions and take advantage of it, that will create incentives that will make it easier for us to follow these best practices. So I think this is something very important, that it can stimulate us to work smarter in a better way.